Hi guys, welcome back to my YouTube channel, and in today's video we're going to be using secant slopes to find the slope of a tangent line. This is chapter 1 of Math 31. Okay guys, so this is the question we're going to be doing today. Let's start by reading it. The point P lies on the curve y equals negative x squared plus 6x minus 8. So part A of the question is asking, if Q is the point, find the slope of the secant line PQ for the following values of x. And they've given us an array of values for x that we can plug into the equation to find the slope. I'm going to read B, C, and D, and then we can get started on part A. So part B is asking, use the results of part A and guess the value of the slope of the tangent line to the curve at point P. Okay, and C is asking, using the slope from part B, find the equation of the tangent line to the curve at point P. And then D is asking, sketch the curve, tangent line, and two secant lines. Okay, so we're going to start off by solving for part A. It's asking us to find the slope of the secant line using the following values of x. Okay guys, so we know that the slope can be represented by m using y equals mx plus b formula, so we use m as our slope. And we know that our slope is basically finding the rate of change, and the equation for that is delta y over delta x, which essentially just means y2 minus y1 over x2 minus x1. When we are given 2 points, we can use this equation to find the slope, and we have been given the 2 points here back in the question. This is point 1, and this is point 2, okay? Now what we're going to do is we're going to substitute y2, y1, x2, and x1. So here you can see that point 1, our x1 will go here, and our y1 will go here. Our x2 will go here, and our y2 will go here. Okay, I'm going to write it out. Okay, guys, so here I substituted the values that we have, okay? This is y2, we got y2 from here. This is y1, which we got from this point. This is x2, which we got from point 2, and this is y1, where we got from point 1. Okay, now we can simplify it even more, because there's a 0, and our m secant line is going to be negative x squared minus 6x minus 8 over x minus 2. That's going to be our final equation to find the secant line. I'm going to write it out. Okay guys, so now I wrote the equation which will give us our slope. And the way we are going to find the value of our slope is by plugging each of these x values into the equation and see where it's approaching, okay? We're going to take turns and plug all of these values into the equation, and all of them should be approaching to one specific number, okay? I'm going to write them all out and I'll show you where it's approaching. Okay guys, now because since there were a lot of test values to use, I chose these 4 to show you guys what's going on with the equation, okay? I chose these 4, 2.1, 2.01, 1.9, and 1.99 as x. Well, when we plug those values into this equation, we can see it's getting closer and closer to 2. Okay, from here it's approaching 1.9, then 1.99, and then it stops there. And then the other side, when we start at 1.9, it's approaching 2 again, except it's getting closer from the opposite side. One second, let me find a better way to reword this. Okay guys, I drew a number line so it's better for you to visualize. This side, when you plug in 2.1, and then 2.01 into the equation as x, you can see that when the x is approaching 2, when x is approaching 2 from the right side, the y value is also approaching 2. It's getting closer and closer to 2, okay? And then when you plug in 1.9 and then 1.99, it's getting closer and closer to 2 from the left side. It's approaching 2 from the left side. Okay, so now that we know that whenever our x approaches 2, our y also approaches 2, which means that our slope value, our m value, is going to be 2. Although it's not explicitly given to us, you can't get the answer as, even if you plug in 2, you can see that it will be undefined. And since it's going to be undefined, you have to analyze what the value is approaching, and in this case, it's approaching 2, which makes 2 our slope. Okay, our m value is going to be 2. Okay, so here it says in part B, using the results of part A, guess the value of the slope of the tangent line to the curve at P20. Okay, this is part A. Plugging in these values is part A, and we're supposed to guess, and that's exactly what we did. We guessed that our slope is going to be 2 because whenever x approaches 2, y also approaches 2, okay? So our m value, our slope, is going to be 2. Okay, and then part B is, part B is done. Part C is asking, using the slope from part B, find the equation of the tangent line to the curve at P20. This is very easy. You can just use point slope form to find the equation. I'm going to write it on the board. Okay, guys, and because now we have the points, we have 2 points and we have the slope, it's going to be very easy for us to find the equation. All we can do is use intercept form or point slope form. I'm going to use intercept form, which is y equals mx plus b. We have the m and we have our x and our y, okay? So now what we're going to do is we're going to solve for b and then we'll have our equation. That's the only thing we're missing. We have our m, but we need to find our b, okay? So you plug in everything that we're supposed to plug in. I'll show you. Okay, guys, now we plugged in everything we have. We plugged in our y, which is 0, our m, which is 2, and our x, which is 2, and then we solve for b using algebra, and when we solve, we get b as -4. Okay, so now our equation is going to follow the y equals mx plus b pattern. We have our m and we have our b, making our equation y equals 2x minus 4. That's going to be our equation. I'm going to write it out. Okay, guys, as it said again, using the slope from part B, which is 2, find the equation of the tangent line to the curve at P20. We used P20 and used slope-intercept form to find our equation, and our equation came out to be y equals 2x minus 4. That is the equation of our tangent line. Okay. And part D. Sketch the curve, the tangent line, and 2 secant lines. I'm not going to sketch it on the whiteboard because it's going to be hard to understand. I will just put up a picture on the screen, and this is going to be our graph. One is going to be a parabola because it's one of our equations is to the power of 2, and the tangent line, of course, we're going to graph that, and the secant line, we can just choose any 2 lines that touch the graph or intersect the graph. Also, because I graphed this, I want you guys to know that the tangent touches the graph at exactly 1 point, and the secant touches it at 2 points, and it can even intersect the graph. Okay, this is going to be the graph. Okay, guys, so that was a very basic question from chapter 1 where we have to find the slope of the tangent line using the secant line. So I hope the video was easy to follow along with, and yeah, that's all for today. See you guys next time. Bye.